Hello everyone, we are team She for Tech from Triple IT Naya, and today we are excited to present our work on industrial practices and methodologies. Before we dive into our topic, let me introduce our incredible team.
I am Anjali Dahiria. This is Kusum Patel.
I am Rimjim Sharma,
I am Shanini Singh.
and this was all about my team. Let us move on to the first question of the topic. Today, I will be presenting an analysis of the electric scooter app and the top 10 features that could enhance its functionality and user experiences. These features were mind mapped to reflect real world user needs, ranging from safety and convenience to efficiency and personalization. The features we identified were emergency crash detection and SOS, battery swap station locator and booking, anti theft alerts, vehicle health diagnostic, Google Map integration, parking spot recommender, weather responsive ride suggestions, geo-fenced safety zones, multi-user profiles, and emergency crash detection. Now, out of all these, the top 5 features are crash detection and SOS. This guarantees instant alerting of emergency contacts and authorities in the event of an accident. It significantly improves rider safety and builds user trust in the brand. Battery swap at station locator and booking. This solves one of the biggest user concern, battery anxiety. It allows users to quickly find and book swap stations, enabling smoother and uninterrupted rides. Next one is anti-theft alerts. By offering real-time notifications for unauthorized movements, this feature boosts scooter security and gives peace of mind to the users. Geofence safety zones. This is especially useful for families and shared users, allowing the vehicle's movement to be restricted with defined safe zones, enhancing control and safety. Weather based ride suggestions. Leveraging real time weather and this feature recommends ideal ride times and alerts users about harsh conditions, ensuring both comfort and safety. By prioritizing these 5 features, the app can not only solve critical user pain points but also position itself as a smart, secure, and user friendly platform. Let's move on to the next question. The next questions talk about what are the storage features and what we can do to improve this more. For designing the document storage feature, 2 key aspects are essential: usability and security. For on the usability side, we must focus on a user friendly upload interface, a categorized storage system, and multi device cloud sync to ensure a seamless experience. Additional features like alerts and expiry reminders, dashboard integration in read only mode, and offline access enhance convenience and ensure accessibility anytime, anywhere. Now, on the security architecture side, protecting user documents is critical. This includes end to end encryption using AES 256 and HTTPS, along with strong user authentication such as biometrics or OTP. We implement role based access control, token based API access, and activity monitoring logs for better traceability. Storage will be hosted on a secure GDPR compliant cloud services like AWS or Firebase, supported by automatic backups and data recovery to prevent any data loss. Together, these design and security considerations ensure the feature is both user centric and robust against threats. Let's move on to the next question that will be discussed by Kusum Patel.
As Rimjim said, I am Kusum Patel and I'll be discussing the third question. So the first issue that the customers are complaining about the sudden battery drain. Imagine you're riding and a battery suddenly drops from 20% to 0%. Not cool, right? So the root cause for this could be due to inaccurate state of charge estimation. Basically, the system thinks the battery has more power left than its actual does. Test scenarios. To fix and test these issues, we can run a few scenarios. Stimulate a sudden drop of battery percentage. For example, check if it is drop instantly from 20 to 0%. Compare the real battery usage during a ride and what a app shows. If there is a mismatch, it is a red flag. Test warning alerts. The scooter should give alerts at 15%, 10%, and 5%. If those alerts don't work, users won't be prepared. This will help us to catch bugs in battery monitoring and improves user trust in the battery display. Issue 2. App not updating in time. The second complaint is about the app not showing real-time updates. Sometimes users see old data and app is just too late. Root cause. This is mostly due to cloud sync delays and network instability. Test scenarios. To make sure the app is fixed, here's what we test. Update delay test in different network conditions like 4G, 3G or Wi-Fi. Offline catching. Does the app still show useful information when it is offline? Sync and retry logic. If syncing fails once, does it try again? And how fast? These tests help us to make app feel faster and more reliable, which is super important for any smart vehicle. Conclusion. So we looked at two major issues, battery dropping suddenly and app delays, and how to identify the root cause and design strong test cases to solve them. Thank you. The next question will be discussed by Anjali.
I'm Anjali Dahria and will be discussing question 5th and question 6th. Now let's look at this slide which focus on prioritizing the top 10 feature based on customer need, usage scenario and overall impact. We have categorized each features as either P1 or P2, where P1 indicate a high priority features essential for core functionality or user safety, and P2 include important but secondary enhancement. We have also ranked them from 1 to 10 in term of priority. Starting with P1 feature, first one is Google Map integration. This is absolutely critical for navigation, real-time tracking and route planning. It's a central pillar of the rider experience. The second one is emergency crash detection and SOS, a life-saving feature that automatically alert emergency contact and share the user location. It's vital for rider safety. The third one is battery swap station locator and booking. In EV ecosystem, range anxiety is a real concern. This feature smooths the riding experience and ensure uninterrupted journey. Fourth one is geofence safety zone text. Help rider in safety area like school zone by automatically alerting or adjusting right parameter. The fifth one is vehicle health diagnostic. Prevent unexpected breakdown and support timely maintenance, improving both safety and convenience. The sixth one is anti-theft alert, essential for peace or mind of mind. It's not only protect the vehicle but also boost the confidence of the rider. Now for the P2 feature, which are valuable but not initial critical. Uh, Weather responsive ride suggestion, a comfort and planning feature that adds value especially in cities with variable weather, though it's rely on third party app. Parking spot recommender, improve user convenience but isn't essential for ride safety or completion. The ninth one is ride history and trip planner, great for power user carbon footprinting tracking and understanding usage safety, but not a daily ride for everyone. The 10th one is multi-user profile or family sharing. Very useful in shared vehicle scenario or household with multiple rider, but it's more of a luxury than a necessity. Let's move on to the next question. This slide addresses a critical challenge in connected vehicle ecosystem. The performance issue that rise when collecting, updating and syncing data from the vehicle to the cloud and then back to the user app. Although the data it's already being collected in the cloud, there are several bottlenecks that hinders smooth operation. Let's walk through the key problem and propose solution. First one is poor network connectivity. One major challenge is unstable or weak connectivity in a certain area. To tackle this, we suggest using intelligent edge buffering and delay tolerant networking. These approaches allow the system to store data temporarily and transmit it once the network is available, ensuring no data loss and continuous functionality. The second one is syncing lag. Sync delay between the cloud and the app can lead to outdated information on the user interference. Implementing real-time push via WebSocket enable two-way instant communication, ensuring updates are reflected in the app as soon as they happen. The third one is slow API response. Backend API can often become a bottleneck due to due to latency or server overload. To improve this, we recommend a combination of serverless microservice caching and edge API. This method distribute the load and bring computing closer to the data sources, significantly speeding up the response time. The fourth one is non-optimized vehicle firmware. Sometimes the issue begin in the vehicle itself. Non-optimized firmware may generate too much data or fail to process it efficiently. Solution here include onboard filtering and firmware level AI pre-processing. So the relevant and redefined data is sent to the cloud. The fifth one is network throttling. In a scenario where bandwidth is restricted, data flow can be severely impacted. Adaptive streaming and data prioritization help address this by dynamically adjusting the amount and importance of data being transmitted based on available bandwidth. So the next question will be discussed by our teammate Shalini.
I am Shalini Singh and I will be presenting question number 8 and 9. So firstly, to begin with question number 8, let's begin with the primary goal for the new version of our electric vehicle. First is improving customer satisfaction. This means actively addressing the past complaints, enhancing the user experiences, and ultimately building trust and loyalty. Second is that we aim to reach the second position in the market by leveraging the innovative features and a sharp product design. Strategic positioning and differentiation are key here. Next one is a bold goal is that is increasing the sales by 50% within 6 months. Like we plan to do this by delivering better value and performance, enticing both the new and the returning users. Fourth point is to our post-launch vision is crystal clear, like zero key issues after the launch. That requires rigorous testing and quality assurances from the get-go. And finally, we aim to achieve 10% profit per unit by optimizing manufacturing, materials, and the supply chain, all while ensuring product quality. These are the goals. Second, moving on to the features that align with these goals and deliver tangible values to the users. We start with Google Maps integration, like for real-time turn-by-turn navigation, smarter route planning, and reduced travel time. Then comes the battery swap station, locator and booking. This helps the riders find and reserve nearby stations, minimizing downtime. The next point is the parking spot recommender, which is a city smart feature that uses crowdsource and real-time data to find authorized spots, making urban commutes stress-free. We also have a weather responsive ride suggestions. This adjusts routes based on live weather updates, helping users avoid slippery or unsafe paths. There is emergency crash also, an SOS which automatically alerts emergency contacts with the rider's live location. And lastly, there is a geofence safety zone which we can add in the app, which allows the system to alert riders or limit vehicle functionality in unsafe areas like school zones or accident prone streets. Now moving on to the user interface changes, which will make our app and dashboard more engaging and functional. Like first, a clean and intuitive app design. This includes a minimalistic layout, readable fonts, and simple navigation. We will support both dark and light modes for better accessibility. Second is a dashboard with tabs, which brings quick access to navigation, stats, and documents with a uniform layout across screens for consistency. Third can be we are adding the touchscreen and gesture support, which the users can swipe to switch the screens, tap to zoom into the information, and long press for shortcuts. The goal is simply smooth and responsive interactions. And lastly, color coded indicators, like green shows all systems are go, yellow means caution like low battery, and red signals means urgent issues, and blue indicates connectivity or GPS status. Moving on to the UX changes. To wrap it up, let's focus on user experience enhancements. Like first is real-time notifications. This keep users updated on battery levels, speed, and maintenance needs. It's all about timely alerts that prevent surprises. Second is we will have smooth app navigation, like the app layout is built for ease of use, ensuring new users can find key features without confusion. Third one is predictive battery warnings. We will use smart data analytics to alert users before the battery gets critically low, like avoiding ride disruptions.
Finally, last but not the least is one tap document access. Like the users can access essential documents like license or insurances instantly with just a tap, reducing the hassle on the road. With this UX updates, we are creating a ride experience that's not just smarter but safe and more convenient. Now we will be moving on to the next question, which is question number 9. So when a company is working on a new version of an electric vehicle, it is crucial to track the right set of metrics to evaluate performance and growth. These metrics are divided into two key categories like business metrics and operational metrics. Let's look first at the business metrics. This help access the overall financial health and strategic positioning of the company. We start with the revenue, which reassures or which measures total sales over a period. Like this is a direct indicator of financial performance. Then comes profit margin, which shows how efficiently the company is generating profit per unit sold. Market share is also critical. It reflects where the company stands among its competitors. Next, we have customer acquisition cost or CAC, which tells us how much is spent to bring in a new customer. And finally, customer lifetime value or CLV, which captures the total value a customer brings over their relationship within the company. Now, shifting to the operational metrics, this reflect how efficiently the vehicle is being produced and delivered. The product quality is key here. It includes the defect rate and the post sale performance of the product. Production lead time measures how quickly the vehicle is manufactured and ready for delivery. The on time delivery, which is OTD, shows how reliably orders are being fulfilled within the promised lifetime. We also track warranty claim rate, which signals product issues based on returns or complaints. And finally, the first time, first fix, which highlights how often customer issues are resolved in a single attempt. Something vital for customer satisfaction. So, by monitoring these metrics, the companies can strike the right balance between profitability, customer experience, and operational excellence, paving the way and path for long term success in the EV market. Now, the next question will be presented by my other teammate.
So again, this is Kusum and I'll be discussing the question number 11. First and the foremost, we need to make sure the battery charges completely in under 4 hours. This is crucial from the user convenience and commercial usability perspective. Battery charging time must charge fully in under 4 hours. It's a basic need for user convenience. Discharge rate, we test how fast the battery drains during normal and heavy usage, critical for real world range. Low battery alerts, the system should notify users at around 15% battery to prevent mid-ride shutdowns. Battery health and overtime. We check performance after 100, 300 and 500 cycles to measure long-term reliability. Battery sync accuracy. The app and dashboard should show the real-time battery percentage that matches actual levels. Overcoming protection. Charging should stop at 100% to avoid overheating and safety risks. The seventh one will be fast charging safety. If supported, it must be tested for safe performance under thermal stress. 8th, hot weather performance. Batteries are tested at 40 to 50 degrees Celsius to ensure safety and performance in heat. Cold weather performance. Similarly tested in 0 to 10 degree to validate winter efficiency. 10th, rough road endurance. Vibration shouldn't be affect battery housing and performances. These fit into the mind map with 6 branches: charging, alerts and sync, environment, battery life, discharging and long-term usage. Together, this gives a 360-degree battery Q&A framework, absolutely essential for EV team. Now I'll be discussing the mind map. It gives a 360-degree view of all the key areas of battery testing with battery right at the center, branching out the 6 major categories. First, charging. We check if charging complete in under 4 hours, stops at 100% and stays safe during fast charging. Next, alerts and sync. We test if battery levels sync in real time with the app and whether users can get timely low battery alerts. Next is environment tests. Ensure the battery performs well in extreme climates from 0 to 50 degrees Celsius. Battery life focuses on how the battery holds up after the repeated discharge cycles and estimate its lifespan. In discharging test, we monitor how quickly the battery drains during normal versus high speed usage and how much it loses when ideal. And finally, long term usage. Simulating real world aging, we study long term degradation and standby drain. Together, these tests gives us a complete picture of how reliable and durable the battery really is. So, in summary, these 10 scenarios and the 6 category mind map gives a complete framework of evaluating EV batteries. If you are designing or testing electric scooters, this should be the non-negotiable checkpoints in Q&A process. So this will be the end of the PPT.
Thank
Thank you everyone for watching our PPT.